So how many of you were able to read slides, code on the slides I just shown, and understand perfectly everything? Anyone who was not able, who's doing programming on a daily basis, not being able to follow along these code lines? Can you guess what programming language this is? And no, this is not a Unison. Louder, please. This is Algo 68, programming language older even than myself. So the question is, in the terms of internet age, this is ancient programming language. You correctly noted that this is predecessor to Pascal and Modulo 2 and Oberon, this line of languages. But how come we can understand this programming language even today? So this probably means some of the fundamental things are still the same up to this day. So in the age of AI, well, the present age of last 2 years, the question is how stay relevant in our profession. And most of us, under the pressure of the hype and media and influencers, will start heavily learning how to use AI, how to do vibe coding. But one more way to stay relevant and secure a future is to learn something that is not mainstream. Well, you will be gambling a bit, because today everyone knows Java, Python, JavaScript, object-oriented programming. That's the mainstream. That's the baseline. But if you know, for example, actor model or event modeling, if you're experimenting with WebAssembly, these are the things that are coming. They are on the horizon. We are pretty much sure that sooner or later WebAssembly will become a mainstream. However, knowledge of these techniques or paradigms like functional programming will get you to the top 10 or 15 or 20%. Beyond that, you need to look into things which are currently being researched, like quantum computing or formal verification. You need to at least get informed about it so you can follow the progress of these research topics and maybe play it a bit hazard, but win in the long run. So today I'm going to present something that is still in the research phase, and that is content addressable programming. One implementation of this concept is Unison programming language. Anyone here who read Scala Red Book about functional programming in Scala? Well, now you know what authors did after writing publishing the book. Paul Cesano and Runar Bjarnason started working on Unison programming language. Unison is very similar to Haskell. It's modern, strongly typed, purely functional programming language, strictly evaluated. It's open source, and the best thing of all, these three guys, Ari Irani along with them, they are developing not only new programming language, they are developing complete universe, and they are getting funding. So, believe it or not, there are venture capitalists in this world who are willing to invest in something that might not be profitable in near future, that might not be profitable ever, but they are supporting their noble goal. And from their perspective, they are doing something they love with passion and getting paid for it. You cannot get better than that. Research on the Unison programming language started in 2013, and first public announcement was in 2014 in the Strange Loop conference. 2 years after that, Unison computing was incorporated, and the first public alpha was released in 2019. In 2021, Unison Share Community Hub was released. Remember, they're building everything from the scratch, whole universe, so this would be equivalent of the GitHub code sharing HubSpot. In 2024, they launched Unison Cloud, which is cloud as it was supposed to be. Because if you remember, 20 years ago, we were maintaining servers ourselves, then the promise of the public cloud arrived. And the promise was, pay us, we will maintain it for you. We have all these security certificates. Where are we today? You need certified expert for the public cloud to maintain your account. So something is not right there. So Unison Cloud is the promise of the cloud as it was supposed to be. And this year they released Bring Your Own Cloud, so you can now install Unison Cloud infrastructure or on your own hardware. So Unison is centered around one big idea. Definitions should not be referenced by name. Definitions should be referenced by content. So how much one sentence can change? Let's see today. How it works in practice. So you have a definition of your function in Unison programming language, and you run compiler. Compiler will perform syntax analysis, semantic analysis. It will strip it down to abstract syntax tree. And then you will, or compiler will compute SHA-3 cryptographic hash from the abstract syntax tree. In practice, when you start calling one function from another, you're still working with the names. But under the hood, the names of the function you're calling will be converted into hash. So instead of name of the function inc being contained in abstract syntax tree, you have a cryptographic hash of the code which will be executed at that place. And typical question is, what are the chances of collision? So if you're computing hash function from the code, what are the probabilities they will be clash? So I suppose most of us are using Git today. Do you know which cryptographic function Git is using? SHA-1. So converted into human language, if every atom on Earth spit out fresh hash every nanosecond, you would expect your first collision in 46 billion years. In other words, there are high chances something else will happen before clash on the SHA-3 horizon. So let's see what are the consequences of this simple sentence, simple concept around whole languages being built upon. So first thing, every function, every term, every definition, every data structure will be converted into binary, and hash will be computed. Names still do exist. As a developer, of course, you will not write a hash function. You will use names. But the names are just metadata. So internally, hashes are stored, and the names are attached as a metadata, which means that you can change name of the function at will, instantly, without breaking anything. We eliminated whole class of competition for name problems. So renaming is instant, it's painless, it's not breaking anything, because hash is not changed. And this is what our references built upon, hashes. So it's a simple, non-breaking operation, and it takes some time for these things to sink down in your head. Because when you're using any kind of ID, you can recall what simple act of renaming a function means, recompiling everything, and maybe detecting name clash. All of that is gone now. Every function is versioned separately. So what you can see here is a sequence of refactorings of the function inc. In this case, I'm not changing the name. I'm not renaming function. I'm changing the implementation. This is functional programming language, but the functional nature of the code is propagating. So this is a append-only code base. Unlike Git, where you introduce new version of a function, and simply override the existing one previous one. Here, as you're refactoring, you will produce new versions of the same function. From the perspective of append-only code base, this will be completely new functions. So this means that you can evolve function over time. Again, there won't be any kind of clashes, as you will see, because we have append-only code base. So each function will be compiled separately and stored inside of a database. And this may sound a bit scary, storing code in the database, but the thing is, we are all doing it today. We are just not fully aware of it. Because Git is a database of code. And with Git, you're using specialized tool. Well, with Unison, you also use specialized tool. It's just that it's called UCM, Unison Code Manager, and commands are pretty much the same. Because in its essence, you're doing the same operations you would do anyway. You produce new code, you store it in a database, you may fetch it, version it, push it to the central repo for code sharing. It's only that Git is storing textual files, Git is working with textual files. Here we are working with functions. Git is computing hashes of of content of the file system. Unison is computing hashes of abstract syntax trees computed from functions. When you look at the cryptographic functions, Git is using SHA-1, Unison is using SHA-3, so stronger guarantees there as well. But probably most drastic difference between Git and Unison is in Git you have syntax diffs on the textual files, and with Unison you have semantic diffs. Interesting consequence of this way of working with the code is you have a guarantee that your repository will never ever be broken. Why? Because if you can compile your code, you will be able to store it inside of the code base. If you cannot compile it, hash is not produced from the syntax tree, you don't have anything to store. So if my colleague is pushing code to the code base, he's actually pushing syntactically, semantically correct code that was converted into binary format. So when I pull it from the code base, I have a strong guarantee that I will be able to compile it. And again, all these things will sink down after this talk, because it takes some time to understand what we took for granted up until now, what are the possibilities that this is opening. No more textual files, and this sounds scary. Why is that? Because Unison Code Manager is not working with textual files. It's working with functions which are being compiled, stored inside of the database. You have a single, usually when you're working with Unison, you have a single textual file called scratch file. And the cycle of development looks like this. You start with empty scratch file, you write a function, you compile it, and if everything is good, you add it to the code base. And after that, you can completely delete it, wipe it out from the textual file, because you don't need it anymore. You're not storing textual files in your version control, you're storing compile functions. If you want to edit something, there's a command edit, followed by a function name, which will load binary representation of the function, convert it into Unison code, and place it in your scratch file for you to edit. After you're done with the editing, you will update definition in the code base. And again, updating definition is creating new function, even though the name is same, but multiple versions of the same function can exist at the same time in Unison code base. How come no more builds? Well, Technically, yes, you have builds because you need to compile, build your code into binary representation to store it inside of the database. But this is, you could say, perfect incremental compilation. Why? Because at any point in time, you have compiled code in your code base. You will write 1, 2, 3 functions. They will be compiled almost instantly, and you can store them inside of the database. So your perception is, since we are doing incremental compilation all the time, is that it is 0 build time, 0 compilation time. And again, consequences of this are big. Because if we are working together on the same project and I'm a new member in your team, what I will do? I will check out complete project. What is arriving to me locally is a binary code, already compiled, stored in the database. I'll be able to run it right away. Someone else did compilation for me. So I'm pulling binary representation, I'm able to execute it right away. Think of CI/CD pipelines. How long it takes to build? Well, in this scenario, CI/CD pipeline does not have anything to build. And it's a question if it will exist in the same format. So as a general rule, if your function did not change, there's no need to recompile anything, because compilation is done once. Result of the compilation is stored inside of a database. As I said, probably the biggest change is introduction of semantic version control. You can see on the line 2 something that will be detected by both Git and Unison Code Manager. Net connection function replaced something that was there previously. Every version control system will detect that. But as you can see on the lines 5, 6, and 7, I have a detection here that I'm calling 3 functions: connection send, connection receive, and upgrade. And these functions were changed. How does Unison know that? Well, hashes changed. Other people changed the implementation of these 3 functions. They compiled. As a result of compilation, hashes changed. And now Unison can offer me semantic version control that is able to detect that 3 functions I'm calling change their implementation. And this is opening so much space for various new things that we built complex tools so far. And thinking of it, you have referential integrity, because if you're calling something, you're not calling it by name anymore, and name is a bit like a shield. You up until now, you had no information what is hiding behind the shield. But now you're working with hashes, which are representing implementation. So whole classes of attacks are not possible anymore. Today we had a talk about security in the supply chain. Various attacks that can occur. You have guarantee for the integrity of your code. If anyone changes implementation of the function your code is calling, you will explicitly know about that. You will not stand naked there being attacked by various changes in the implementation. And again, it's interesting that one simple idea can propagate on so many levels. In Unison, as I said, multiple versions can coexist in peace. In Git, you have a situation like this. You wrote utility function, and you call it from 3 places. If you refactor this function, produce new version of your utility function, in all the places where you call this function, you need to upgrade call references. In Unison, you have ability to refactor slowly. You're not forced to refactor everything all at once. Or if you have a specific need, for some pieces of your code to call previous versions of the function, you will be able to do so. Unlike Git, which is overriding previous implementations so that the only thing you can access is the latest version of the function, in Unison, multiple versions can coexist at the same time. Dependency hell, it exists. I saw it. So, typical reason for dependency hell are transitive dependencies and so-called diamond structure. So let's imagine I'm writing application in the version 1, which is calling utility function B, depending on the version 1 of the library. And over time, second version of the library is being released. Some of the functions are being changed. Some of the functions may be removed, and they added something I need. So for the implementation of the function C, I will use a library in the version 2. So what will happen if I try to write and compile code which is calling C? Now I have a problem. I have a problem because I have two versions of my library in my code. In most mainstream languages, this cannot exist. This is impossible. In Unison, this is indeed possible, to the extent that if I want, I can have 3, 5, or 10 versions of the base library. I'm not saying it's good. This is just a tool, and you can misuse it, so you need to be careful. But things like this become possible. So you will be able to ship a project like this. You will buy yourself some time to refactor, but you will not break. If you need to release on Tuesday, you will not break guarantees you gave to your customers. You will be able to launch your product, release next version, and then go and refactor things later on. Of course, this is possibility, not a recommendation. This is not the best practice. What you naturally want to strive to reach is using just a single version. And now it's a matter of a bit of discipline to follow this goal. But you will not be undermined by the technology you're using. Again, side effect of the way Unison is working with the code is built-in serialization. In Unison community, there's a saying, the program is the protocol. So the compiled flat binary representation is actually serialized version of your code. It will be compiled once, of course, stored in a database, and then you can reuse it as many times as you want for the various purposes you might need. There's no need to write serialization or deserialization if you have a data structure. If you can compile it, you just got serialized version of your data structure, no matter what it is. So no need to write serialization, deserialization, no any kind of marshalling needed, no protocols. You're just saving time. And this is coming as a side effect of the technology you're using. Also, if you store any kind of definition data inside of a database, this is strongly typed compiled code you're storing inside of a database. So later on you can load it, it will be properly deserialized and loaded into your application, and you have a guarantee of a data integrity. There's no possibility on a technical level that you will load something in a wrong data structure, the data will be corrupted, or if you're evolving your data structures over time, again, we're coming to the fact that Unison can keep multiple refactored versions of the same data structure over time. So you can store, for example, if you're doing event sourcing, inevitably you will probably be forced to evolve definition of events over time. And this is a challenge. So with Unison, you can support multiple coexisting versions of your events living in peace and the code you're writing will continue working without any changes, because you will never run into a situation of deserializing your data or your events in an improper way and passing out into something that will not be able to handle it. No more impedance mismatch, no more ORM needed. And again, one more side effect. Our unit tests are functions as well. Function calls with arguments are just function calls. They will be compiled once. They can be cached, or to call it stored in Unison code base. And they can exist indefinitely there. The only time where your tests are invalidated is when you refactor the function that you're testing. But if you have long-lived definition of a function, your tests are executed once, you compile them, you store them inside of a database, that's it. No need to pay attention to them, no need to run them again, because why you would want to run again test against implementation of function that did not change? And remember, if any of the functions you're calling changed, this will also affect your function. The hash of the function will change if any of the functions you're calling changed. So the changes will propagate indeed, but you have a strong guarantee if the hash of your function is unchanged, that's it. You don't have to execute tests anymore indefinitely. And again, think about the typical CI/CD pipeline. With big projects, over time, amount of regression tests will grow. If you can execute them once, store indefinitely, you're simply eliminating execution of these tests. And this in practice means that you will not have 7 hours or 15 hours, or on very big projects even more, a running of tests every single time. And this is saving time, computing power, electricity, whatever aspect you want, or your nerves, whatever aspect you want to find in this. Unison has something that's called adaptive service graph compression. Because now there's possibility for you, technical support, to send code over the wire. So what you can see here is the actual code that can be executed in Unison cloud environment, or any kind of distributed setup of Unison. So you have forcat function. Bob is the name of the remote node you're contacting. Factorial of 6 is function call with an argument. And a do is a keyword that will introduce delayed computation. So do factorial 6, keyword do will prevent factorial 6 from being executed on this machine. And it goes like this. Node A sends do factorial 6 to remote machine, or pardon me, factorial 6 to machine B. What is being sent under the hood is the hash of the function with argument 6. And node B receives hash and arguments and says, I'm not familiar with this hash. Can you provide me code, binary code for the function this hash represents? Node A will receive this request. It will send definition, and then after node B collects all the dependencies, it will be able to execute this locally. So what happened here? Instead of node A sending something like JSON over the wire, executing on machine B, and machine B responds back with, again, JSON, which needs to be serialized and deserialized, what you have here is a node B collecting dependencies and starting executing code locally. So you could say you have some kind of just-in-time deployment where over time, as calls are progressing, code will migrate to the place of the execution. And I won't go further into this, but there are some serious consequences of this. It takes some time for everyone to understand. Now you're able to send code to a remote location to be executed, and even more, remote location will be able to request code that should be executed there. So you could say you have microservices without drawbacks, microservices as they were supposed to be. Because you don't have network boundary on every call. Over time, code will migrate over the distributed network setup you have, and nodes will collect the code that's needed, all the dependencies that are needed. It will execute them, and on top of that, your remote procedure calls will have full type guarantees. So you're eliminating any malicious parties or any slippage of attention that will result in sending something that cannot be executed. So teams working together can independently develop and deploy, and whatever they deploy will migrate naturally, seamlessly over the boundaries of nodes in distributed setup. And you have a guarantee that your code will never call an outdated version of a function. Because if I deploy new version of my code, which is calling new function, that will result in a node attempting to execute my code, saying, okay, here is the call to the dependent function. Based on the hash, I don't have that code. Please supply me dependencies which are missing. So again, there's a strong guarantee of integrity of your code. You will never run into a situation of running outdated code. You will be able to deploy it on just one node and let it spread like a virus, but a good virus. So, do you remember what happened last time when we had one big idea? It took some time to get the traction, but you can see today it's mainstream. Well, Unison may or may not become mainstream. You don't have to use it. But if you start playing with it, it will make you reconsider things that you're already doing in your programming language and maybe realized some things could be better. Thank you. So we have, I think, 3 minutes for questions.
Sorry.
Sure.
Getting ready for the questions. Sorry, but I mean, the gentleman almost died yesterday, so we're going to give him priority, okay? Still the haunting going on. So let's go. So then we have another person. Who else? Ooh, you're a popular gal, aren't you? Many questions. Oh, good. So what you're not seeing here is that every person is patiently going, yes, I have a question, but this is the first person to ask a question.
Okay, I'll be quick. What does it look to work with a Unison code base? You said there's a scratch pad that you load a function you need to work on, but how do I review like 10 functions? How do I, how do I assess what this code base is doing on a whole?
So,
go to the center of the stage. We need to see you.
So I did not want to cram too much into this presentation. So I could show you, but unfortunately we are short on time. I will just tell you that there's a simple text file. You start UCM in the command line. It will monitor your scratch file. It will detect any changes, compile them, and offer you if everything is good, if everything's been compiled properly. It will say, run update to add this function, to update this function, or run add if this is a new function. So it's a pretty much, and you're writing small functions. In my experience with using LLMs is since I'm writing small functions, the context is smaller, and my subjective impression is that LLMs are working better with Unison code, simply because of the scope is smaller. You don't have projects anymore in classical sense. Project is now collection of various functions under the same namespace.
Okay, thank you.
You're welcome.
Can you pass the microphone to the next person? People coming in, sit down. Don't worry, we have a few more questions, and then we're getting on with the closing. Yes, sir.
So, how easy can other languages adopt these concepts as a mainstream language? Because it will probably be difficult for everybody to switch to Unison, but could, like, for example, Java use the concepts behind Unison?
There was a slide while ideas, and it's not what you think, which I removed because it's too much for a short, relatively short presentation like this one. But this is a binary representation which is being decompiled into Unison programming language. So hypothetically, if you have a language that is supporting some of the concepts in the Unison, like algebraic effects, etc., which can be compiled into same binary representation, you and I can work on the same code base, and I can say, please edit this function, and what would render for me would be Python 2020, for example. So there's no technical boundaries or any kind of problems with team working in multiple languages, which would be compiling to the same binary, which is something we had in JVM ecosystem at the moment.
Let's go, pass it on. The sisterhood of the traveling microphone.
Hi. What are the guarantees that Unison will stay on this direction, for example? You know, like in Scala, you know, you have this Akka and it changed the...
Are you asking for guarantees in tech? Are you sure?
Well, it comes to two things. So far, through, I think, 2 rounds of financing, they collected over, I think, $15 million. One. And in the community, which is small but passionate, I detect a Rust level of passion and devotion, which is, I think, guaranteed that maybe this will not become mainstream, but it will at least make some people happy.
Are we good with the questions? Ready to get on with the closing? No, one more. Okay, let's go.
Do you have any production releases for some system that's written in Unison?
Yes, actually, before this conference, I wrote a Telegram bot, but I did not have time to complete it. I wanted to show this is not just a theory. This can work. So hopefully next year for this conference, you will have fully functional bot written in Unison and deployed into Unison Cloud.
Give it up, come on. Thank you for being the last person to close.
Thank you, Trinity.